Chapter 4, Section 6.6, Part 1 Video. In this section, we'll be looking at quadratic regression. And so we'll be doing this on a calculator. And I'll show you some techniques to get everything that you need in order to be successful in this. On quadratic regressions, you have to have 3 points to do a quadratic regression. Everything else, every other type of function just takes 2. Quadratics has to have 3. So just kind of be mindful of that, and that'll be self-evident as we progress through. The first problem is just it's kind of an oddball, but we're going to show you how to do it. A ball is thrown upward at a speed of v feet per second, rises at a distance d and t seconds, given by d equals 6 plus v sub t equals or minus 16t squared. So they didn't give us the initial velocity, right? So write an equation whose solution is the time it takes the ball thrown at 74 feet per second to rise 30 feet. Do not solve it. Okay, so here we go. So 6 plus, that bad down there, plus 74 v, not v, sorry, t minus 16t squared equals to 30. So you're substituting the 74 feet per second in for v, and your distance is 30. Okay, so you're just setting it equal to 30. All right. Now, let's look at this one. Find a formula whose quadratic function, find a formula for the quadratic function whose graph has a y-intercept of 9 and 2 zeros at 3 and 5. Well, first things first, we need to write the ordered pairs for these, okay? So we go 0, 9, and 3, 0, and 5, 0. All right, so your solutions that they will be showing is going to be, some of them will be in factored form. Well, I guess a lot of them will be in factored form, but some of them are even in vertex form, but a basic standard form of quadratic still works. I checked it, so we're good on this. So here we go. So we got 3 points, right? So we're going to do quadratic regression. So second plus 4. Remember, that clears all my list, right? Let me make sure I got my points. 3 and 5 and 9. Good. All right. So stat, edit. 0 enter, 3 enter, 5 enter. Yeah. And then 9 enter, 0 enter, 0 enter. So I got my y-intercept, my 2 x-intercepts, right? So that's in. And so if I hit stat, calc number 5, L1, L2 is not a problem. I can go ahead and store this, vars, arrow, enter, enter. And then, of course, I can perform the quadratic regression. Now, we're not needing r squared or r or anything like that. We're just needing a, b, and c. So if a would be the quadratic coefficient, b would be the linear coefficient, and c is the constant. Let's see if they told us anything about, nope, they just said do it. So they didn't say what. So I can hit y equals, and here it is written out as the equation. So I'm just basically going to take, let me do something real quick. There we go. So I'll take this equation and just kind of write it here. So 0.6 x squared minus 4.8 x. Don't do plus minus, just it's minus plus 9. And that should do it. Okay, that it should take that because that is an equivalent quadratic equation for those points. Now, let's do another one. This time they give us a graph, right? So no big deal. We have all the points, right? -2, 0, 0, 2, and 1, 0. Now, we're going to take all three of these points and we're going to put them in a quadratic regression, right? Put them in our calculator. So you get this back up and hit clear. All right, so second plus 4, enter, clears all my list. And then I'll hit stat, enter, and make sure I'm back on L1. So let me look at my list. -2, 0, and 1. So -2, enter, 0, enter, 1, enter. And then let's look at my y's. 0, 2, 0. Okay. 0, enter, 2, 0. And now I go stat, calc, number 5, quadratic regression. I just get in the habit of doing this, folks, and storing it in Y1. So that's vars, arrow to the right, enter, enter. And then it's -1, -1, 2. Okay, -1, -1, 2. So here we go. -x squared, -x plus 2. That's our equation. So let's do one more, because this one kind of gets you where you need to be. And note they only gave us 2 points, right? So I need to show you how to get the third point. Now, let me grab graph here. And they tell us we have a vertex of 1, 4, and then a y-intercept of 6. So that's up here. Let me do this. Make it, there we go. All right, so in a quadratic, you have what is called symmetry, axis of symmetry, which is basically, if I fold it down through the vertex, it should line right back up on itself, right? So what you have to understand is how to get the other point is this y0, this y-intercept, this 0, 6 is 1 space away. So if I go 1 space away here, the output should be, guess what? 6. So if I go 1, 4, 0, 6, and 2, 6. Okay, so that's going to give me my 3 points. So just make sure you understand, if they give you 2 points, if you'll plot them, and however over to the left or right that point is from the vertex, if you go over to the left or right, the opposite of where the initial point is, see, I was over 1 left, I go over 1 right, and I got the same output, because they should lay right up on top of one another if you fold it about that line. That each point maintains the same distance away from the vertex. So you can kind of think of it like this. I'm 1 away here, I'm 1 away there. Okay, if you kind of draw an imaginary line. 1 here, and then pull the point. Okay, so let's do the regression on this. So let me clear and go second plus 4, enter, stat, and let me grab my points. 1, 0, 2. 1, 0, 2. Now let me grab my y's. 4, 6, and 6. So I'll go 4, 6, and 6. All right, now stat, arrow number 5, which is quadratic, and vars, arrow, enter, enter for y1, and then of course calculate, boom, and it gives me 2, -4, and 6. Okay, 2, -4, and 6. So here we go. So this would be 2, 2x squared negative 4x plus 6. Okay? All right, so this concludes part 1 of chapter 4, section 6.6's video.